The electric guitar dates back to the 1920s. The original idea was to amplify the sound of the acoustic guitar. The first commercially successful model came out in 1932. By the 1950s, the instrument underwent a radical change, its body evolving from the traditional hollow shape to a thin, solid block of wood. Guitar bodies are usually made of mahogany, poplar, or certain maple species, lightweight woods that are flexible enough to produce the right balance of treble, mid-range, and bass vibrations. Workers first saw a plank of wood into specific widths. They plane the pieces to a specific thickness, usually in the range of 5 to 10 centimeters. Then they mark them with the same number so they'll end up in the same guitar. Mixing pieces from different planks would combine different wood densities and make the body vibrate unevenly. Damp wood tends to warp, so the pieces have to go into a heated room until their moisture content drops to less than 6%. This takes about 2 months. Once the wood dries out, workers glue and clamp the pieces together, setting them in a vise for 3 hours until the glue dries. The water-based glue re-wets part of the wood, so the block has to go back into the drying room for another 2 months. When it comes out, it goes onto a holding device. Then, a computer-guided cutting machine uses 8 different heads, one after another, to gradually carve the body shape. This is a semi-acoustic model, so the body has some hollowed-out areas. After a fine sanding to smooth the surface, they trim the contour at a 45-degree angle using a small stainless steel blade. Then they sand again. By this point, they've also inserted round metal fixtures to hold the bolts that'll attach body and neck. To construct the neck, they slice a piece of mahogany or hard rock maple in 2 using a diamond-edged saw for a perfect cut. Then, they glue a 1.27 millimeter thick sheet of maple veneer onto one piece. This will be the front surface of the neck. Now they flip the piece over and glue it to the other one. Flipping inverts the wood grain. This strengthens the neck, enabling it to withstand the tension of the guitar strings. The maple veneer hides and reinforces the joint. They clamp the components in a vise for 3 hours until the glue sets. A computer-guided cutting machine contours the neck shape and cuts a groove down the middle for a steel bar called the truss rod. When the neck bows from tension created by heavy gauge strings, you straighten it by adjusting the protruding end of the truss rod. Next, the fingerboard, the surface against which you press the strings to produce different notes and chords. It's made of maple, ebony, or rosewood. After gluing the fingerboard over the truss rod, they place the neck into a vacuum press. The press sucks out all the air, compressing the components into one solid unit. Once the glue dries, the neck goes onto a computer-guided carving machine. Its 12 different cutting heads finalize the shape. Next, a 22-blade saw simultaneously cuts very precise slots for 22 fret wires, the metal lines on the fingerboard. A worker rounds off and smooths the back of the neck against a belt sander. Then installs the fret wires. The wires are made of nickel and lead. They have teeth on the bottom that grab the wood. That's why it's essential that the slots be a very precise width and depth. Finally, they run the sides of the neck against a sanding belt. This trims off the excess fret wire and rounds off the edges of the fingerboard. Back to the body now. A worker puts it in a silkscreen printer to apply the company name. The ink dries in just seconds under ultraviolet light. After applying a sealant to block the wood's pores, they spray on up to 22 coats of wood stain and lacquer. This protects the wood and gives it a sexy semi or high gloss finish. Now on to the mechanics. An electric guitar works like this. A magnet and coil assembly, called a pickup, works like a mini microphone. It picks up the sound vibrations of the strings and sends them to an amplifier, which sends them to a speaker, which emits that trademark electric guitar sound. Before installing the electronic components, though, a few final steps. After a 6-week curing period, they wet sand the painted and lacquered wood. Then buff until the surface is so glossy, it produces a mirror finish. Then they polish it with wax. If the frets aren't level, the guitar will buzz. So workers color the top of each fret with a marker, then run a sheet of fine sandpaper down the fingerboard. The ink rubs off any frets that are higher than the rest and have to be filed down. But filing flattens the frets' edges, so workers round them off using a special curved file. Then, with very fine sandpaper, they buff away the filing marks. They clean the fingerboard with mineral oil. This also nourishes the rosewood so that it won't dry out and crack. Now they turn an Allen key in the truss rod to straighten out the neck. This gauge measures the curve. When the needle hits 0, the neck is perfectly straight. Now the 6 tuning keys, 1 for each string. Depending on the model, these steel keys are plated with either gold or nickel or painted black. You turn the black acrylic peg to tighten or loosen the string for tuning. Workers use a digital gauge to measure the height of the nut, a thin piece of either bone or very hard plastic with 6 slots to space the strings. If it isn't in precisely the right position, tuning will be off and the strings will buzz. Now the neck is ready to join the body, courtesy of 4 bolts driven from the back of the instrument. They fit into those round metal fixtures we saw in the previous segment. And now, the electronic components. Workers begin by soldering control knobs for the volume and tone to the pickup selector switch, the switch that activates any of the pickups, sets of magnets with wire coiled around them. Like miniature microphones, they pick up the sound vibrations entering their magnetic field, transform them into electronic signals, which then go out to the amplifier and speaker. One pickup will be just above the bridge, a brass piece that anchors the other end of the strings. The pickup has 1 magnet and wire coil for each string. Standard electric guitars don't have a pickup at the bridge, but this model has one to enable the instrument to also sound like an acoustic guitar. You can even use the electric and acoustic sounds together. Workers drill holes in the body for installing the bridge, using a template as a guide. They attach the bridge with screws. Then install the bridge pickup just above it and the body and neck pickups above that. Then they flip her over and hook up what's called the tremolo, a lever-activated set of steel springs that temporarily loosen the guitar strings. The musician uses the tremolo on select notes and chords to create a quivering effect, that distinctive electric guitar sound. The volume and tone knobs come next, tucked into a cavity in the back, then secured to the front with a nut. Now, the pickup selector switch. It also comes through the back to the front of the instrument. Then they add the last electronic component, a jack for the cable going to the amplifier. They plug in the cable and, flicking the selector switch, do a tap test.